Hey everyone, welcome back to TechOps tutorial. In our previous tutorial, we have covered the theory behind multi-container pod in Kubernetes, what they are, why you would use them, and some common patterns like the sidecar, adapter, and ambassador. If you have missed that, I highly recommend checking it out first to get the full background. I will also share the link in the description and also I will add it in the card. Let's quickly recap. Multi-container pods let multiple containers run together inside one pod, sharing the resource like network and storage. This is great for patterns like Sidecar, where the helper container supports the main application. Today we are continuing that topic with a hands-on demo. Think of this as a part 2. We will move from theory to practice, showing you how to create and run multi-container pod in a Kubernetes. This will help you understand better by seeing it in action. So let's get started. As you can see on my screen, I am using Rocky Linux 9.5. On this operating system, I will be showing demo. Let's create a YAML file. So let's add API version v1, kind we will use pod, metadata we will use name as a shared volume pod. Let's add specs. Let's add container, add the name. I will give name as a writer. Add the image. We will use BusyBox. And also we need to add some command to keep a container live. -c. We'll use while loop here. Print the date to data, give the file name. We can mention sleep 5 seconds and close that. We can add volume mounts, give the name shared, data. So this is one container. We will add one more container here. I will use image, BusyBox. Let's add the command. bin sh -c tail-f data /log.txt. This will read the log file and provide the volume. Volume mounts. /data. Shared data, emptyDir. We will give empty directory. That's it. Let's save the file. Let's check what's happening in the YAML file. We are creating a single pod called shared volume-pod with two containers, writer and reader. This is a pod name and these are the two containers. And the writer container, this is the writer container, uses the BusyBox image and writes the current date and time to a file every 5 seconds. And this is a reader container. Reader container also uses the BusyBox and continuously tails the same log file in a real time. Both container mounts the same shared volume at /data backed by a emptyDir. Think of this shared volume like a common clipboard. Both containers can read from it and write too. This emptyDir is the empty storage that exists only as long as the pod is running, perfect for sharing the data between the containers within the pod. Let's apply this pod and check if it is running. Run kubectl apply-f multicontainer-pod.yaml. This is our YAML file which we have created recently. So check if pod is running. This is the pod we have just created. Let's wait for a second. You should see shared volume pod in the running state. That means both containers are up and sharing the volume successfully. Let's check the log from each container individually. Run kubectl logs shared volume -pod -c writer. You won't see any output here. That's expected. The writer container is redirecting its output to a file /data/log.txt, not printing to the terminal, so nothing shows up in this log. Now let's see the reader container. Here you can see this will show the timestamp logs being tailed in a real time. This proves that the shared volume is working. The reader is successfully reading the file being updated by the writer container. Please note, always use -c flag to specify the container when dealing with multi-container pods. Let's jump to the reader container to manually inspect the shared file. Now I am in the container, reader container. So let's cat the file data log.txt. Here you can see it's full of timestamp being written by the writer container, confirming everything works as expected. Now let's exit from the container. Remember, all container inside a pod shares the same lifecycle. If the pod restarts, both container restarts together. If your pod does not start or work as expected, you can check with this command kubectl describe pod and give the pod name. To check for errors or events that might explain what's wrong. So if you'd like to clean up after testing, just delete the pod using kubectl delete. It is in terminating state, so it will get deleted in some time. Let's quickly review what we just did. We created a multi-container pod where one container writes to a shared volume and the other reads from it. We used emptyDir to provide temporary shared storage. Both containers starts and run together, sharing the pod network, lifecycle and volumes. This setup is the basic example of sidecar pattern where a helper container supports the main application. This is great for logging, monitoring or data sync tasks. In real-world use case, for example, a logging sidecar container can gather and process logs while the main application runs separately, all in one pod. So here you can see the shared volume -pod has been deleted. That's it for our demo on multi-container pod. If you found this helpful, please like and share with your tech friends. And also don't forget to subscribe for more Kubernetes videos. Thanks for watching. See you in the next one.